Okay, so I hope everyone had a great spring break. I'm happy you're back. So we're going to pick up with the counting principles, permutations, and combination notes. Okay, so here we go. The fundamental counting principle just says if there are n ways of doing one thing and m ways of doing another, then ooh, darn, I forgot to do my pen. Let me get it then there are n times n ways of doing things. I know this really does not make sense, but we'll take care of it with an example. So you're at a taco bar, and there are am I in here with my pen? There are 3 options for the types of shells, 4 options for the types of filling, and 6 options for the type of toppings. Now, the question is how many different tacos we can make. So, how many shells? There were 3 shells. Okay. I don't know if you remember the word. And means to multiply. There were 4 types of fillings. So, 4 fillings. And then there are 6 types of toppings. Okay. And all you're going to do, according to the counting principle, is multiply them together. So 3 times 4 is 12, times 6 is 72. So there are only 72 different types of tacos. I know some of y'all thinking there should be more. I would agree, as long as there are no beans in them. Okay, let's do one more example. So you have 5 pair of pants, 8 shirts, and 3 ties. How many different outfits? So you're just going to do 5 pants times 8 shirts times 3 ties. So 8 times 5 is 40 times 3. You can make 120 different outfits. Okay. And I bet y'all are still wearing the same outfit you started 3 weeks ago. Right? I know. Okay, permutations. Here's the big thing. Order matters. Okay? There are different things in life where order matters. For instance, your combination you use for your phone, if your Face ID doesn't work, your telephone number, things that don't matter, jelly beans that you put in your mouth, right? Okay, here is this cute little formula. If you do not have a calculator, but we do have one online, please look at that link. Or you're just crazy, like Maurice, you could use this. I know Wilmer would probably do it too, just to prove a point. So let's look at another example. Let's find the number of ways of forming a 3-digit code. To which no digit is repeated. So once you use a 2, you can't use a 2. Okay, so we want 3 numbers, and how many single numbers do we have? And the answer is there are 10 numbers. Okay, so it would be the number 0, 1, 2, all the way up to 9. Okay, so this is going to be a permutation because once I use a number for the first one, I'm only going to have so many numbers left. So if we go back here and look, and this is going to be the most important thing, n is going to be the total number of options. R is what we're looking for. Okay, so bigger number, if you want the easier way to remember, n is always big, r is always the small. Okay, so because order is going to matter, it's going to be an NPR, P meaning permutation. So I have a total of 10 numbers, P and a 3. Now you could plug it into your that equation, but we're going to go to the calculator. Okay, so we're going to hit the number 10, go to math. You see right here where it says probability, we want to go over there And you see right here, NPR, we want to hit that. Ooh, it did not work. Let's try this again. 10, math. I forgot to hit 2, didn't I? Oopsies. 2. This 10 is telling, going in for this N, and then we needed the number 3, and then you hit enter. And there's 720 different codes you can put into your calculator. So your final answer is 720. Okay. Let's try this one. 43 race cars started the Daytona 2007 Daytona 500. How many ways can cars finish first, second, and third? So what was the total number of cars entered into this race? 43. Please be careful. The Daytona 500, that 500 I think deals with the number of laps. We don't care about this number. And then we're interested for first, second, and third. So our R value is going to be 3. Okay, so let's go back to our calculator, hit clear. It's 43, math, probability, number 2, and we want 3. So there's 74,046 different ways we can get a first, second, or third. What was it? 74,046, I think it was. Let's see if that memory's good. Damn good. Okay. I hope this is making sense. Okay, so the last one, combinations. Order is not going to matter. Now, this is where it kind of got me. I always felt like combinations, like a locker combination or combination to open your phone. But since math doesn't make sense, combination order does not matter. Okay, and again, here's the equation. N is still going to stand for the total or the big number, and R is what we're looking for, and that again will be your smaller number. So here we go. This is like a paragraph. Okay, so a state's Department of Transportation plans to develop a new section of interstate highway and receives 16 bids for the project. The state plans to hire 4 of the bidding companies. How many different ways, I can't type well, can be selected from the 16 bidding companies? So my N value is going to be 16. My R is going to be a 4. Does it matter who gets selected in what order? And the answer is no. I just need 4 companies. So this is going to be a combination. Okay, now let's go back to our calculator. Where's my calculator? Hit clear. And it was 16, math, probability. This time we want number 3, the NCR, and we want it for companies. And there is 1,820 different ways of selecting this company, or the companies. Okay. This is my last example. I hope this does make sense. Please, whenever you do a problem, you're going to ask yourself, does order matter? So remember, if order matters, you remember this is going to be a permutation. This will be an NPR. If order does not matter, then you're going to choose, does not matter, I'm slow at this, is going to be NCR. Please make sure you download the calculator from Texas Instrument, and I hope this helps. See you later.